Hey guys, today we're going to talk about probability, and we're on actually chapter 11 in your book. It's page 494, and we're going to talk about probability, and it's a really cool little thing to study because you actually use probability in real life, like weather forecasts and things like that. So first of all, we're going to talk about the definition of probability, and that is, it is the likelihood of an event occurring. Now, what does that mean? It just means it's kind of like how likely is something to happen, okay? So that's the first definition you need to know. Your second definition you need to know is an event. An event is just a possible outcome of something happening, okay? So those are two kind of things you want to keep in the back of your mind. If you flip to page 495, we're going to talk about first relative frequency. Okay, and there's a formula for relative frequency, and I'm going to write it right here. Relative frequency is the number of successful outcomes over the number of total outcomes. And this is our formula for relative frequency, and it's important when we're solving probability. Okay, so with that kept in mind, number of successful outcomes is how likely something is to happen, and then over the total. Okay, let me show you. All right, 11.1a. It says 8 marbles are hidden in a bag, 4 marbles are red, 3 are blue, and 1 is yellow. What is the probability of randomly selecting a blue marble? Okay. So you go back to your problem, how many of the marbles were blue? 3, okay? So we're going to use this formula to find the probability, okay? So you're going to say probability P of the blue marble equals the number of successful outcomes. What is that? That is the blue marbles, and they're 3. So we're going to put that on top, just like our formula, over the total number of marbles, okay? So there's 3 blue and the total is 8, okay? Total of 8, I'm gonna put total here, and 3 blue. Now, this is a fraction. All you're gonna do is divide the numerator by the denominator to get the probability, and you leave it in decimal form, okay? So you can use a calculator, you can do it longhand if you want to. Just simply type in 3 divided by 8 equals, and you're going to get 0.375. That is the probability of sticking your hand in a bag of 8 marbles that contain 3 and pulling out a blue marble, okay? So we're using this formula to determine probability. Now look with me on example 11.1b. It says, through the first 4 months of baseball season, Joshua has 110 hits out of 345 bats. From this data, what is Joshua's probability of getting a base hit when he comes to bat? Okay, so we're going to do it the exact same way. The probability, parentheses, of a base hit equals, we are going to put the number of times he actually got a base hit, which is 110 times, over top of the total times that he was at bat, okay? So 345. Same thing. You simply divide the numerator by the denominator. You divide 110, so you type in 110 divided by 345, and the probability of him getting a base hit is 0.319, okay? And you'll just round it to whatever decimal place it tells you to round. This one says 3. Now, when you do your assignment, your first few questions are asking you for the number of successful outcomes. It's not asking you for the probability, so you would just pick out how likely it would be to happen. You don't actually have to solve, but we'll go over one of those in a minute, okay? Now, with that being said, in section 11.1c, there are rules to probability, and this is something you just need to pay attention to. I'm going to read this little section to kind let you know, it says because relative frequency cannot give a number greater than 1 or less than 0, the rule of probability states that the probability of some event must be between 0 and 1. Okay, so you can have decimals. We have decimals here, but notice they are all positive. You cannot have a negative probability because it is less than 0. If you are looking at a number line, anything negative is less than 0. So, rule number 1, you cannot have a negative probability. Rule number 2, your probability cannot be greater than 1. It can be 1, but it can't be greater than 1. Okay, let's look at your examples. 11.1c. Okay, the A part, it gives you a list of probabilities, 0.1, 0.5, 0.3. And it just asks you, is this a valid probability? Well, when you have this group, you have to add them together to figure that out. If your total is greater than 1, it's not valid. If your total is less than 1, it's not valid, okay? So when you add 0.2 plus 0.5 plus 0.3, you get exactly 1. So it is a valid probability. It is 1 or between 1 or 0, okay? All right, let's look at the B part. B part is fractions. Watch this, okay? You got 2/5, 3/5, and what was my other one? 6/5. Now, like I said, when you are given a list to determine their validity, you have to add them all together. So you can add these fractions so simple, because why? Because your denominators are all the same. So you just add the numerators. Okay, so you've got 2 plus 3 is 5, plus 6 is 11, so you get 11 over 5. Now, that is an improper fraction, and like I said, the probability has to be between 0 and 1. So you're going to have to divide this to see whether it's in between 1 and 0, okay? And we know that it's not going to be because 5 goes into 11 2 times, and then you'll have 1 left over. So 2 and 1/5. So this is not valid. Nope. Your last example on page 497. Let me just erase this right here, and I'm going to put C. Okay, this is 11.1c. Now, watch how your book tries to trick you, because this one, when you add them all up, you add negative 0.3 plus 0.8 plus 0.5, you get 1, okay? But this is still not valid because this probability is a negative number, okay? It doesn't fit into the group of being between 0 and 1. Okay, so in your example it says check that all the individual probabilities are between 0 and 1. The first probability is less than 1, and then it says the sum of the probabilities is 1, and it says state whether the group of probabilities is valid, and it says that the group is not valid since the first rule was not met, okay, because it doesn't it's actually a negative number, it's less than 0. Next, we are going to look at 11.1d. Now, in 11.1d, we are finding the complement of the probabilities, okay? So I'm going to go over these examples with you, and you'll have some in your practice problems. So if you look at example A, you have probability, okay? And it says that it's 0.2. And it wants you to find the complement of this probability. Now, this is a super simple concept. All you are doing is since it has to be between 0 and 1, you are going to say that the complement, and in your book, it's got this little C. This is the complement. You will say 1 minus whatever they give you. Okay, so the complement of this probability, the 0.2, is 0.8. Very simple. Look at B part. It gives you a fraction example. It wants to know the complement of 2/7. Okay? So you are going to do it the exact same way, and you are going to go 1 minus 2/7. Now, your book works it out with fractions. Here's what you can do. You can go to your calculator and you can say 1 minus parentheses 2 divided by 7, and it will give you the decimal form. But if you work it out, fraction form is very easy. You want your denominators to match when you're working with fractions, so you'll change this 1 to 7/7 minus 2/7. Why 7/7? Well, you have to match your denominators, and anything over itself is 1 anyways, okay? So you're just making it easier to evaluate, and so your answer is going to be 5/7. Okay, so whether you give me the decimal form or the fraction form, I don't care, just as long as you get that the complement, whatever probability you have, has to be subtracted from 1. And then lastly, we'll look at our C example, where it says a bag contains 4 green discs, 7 blue discs, and 8 purple discs. Find the complement of choosing a purple disc. Okay, so this one is a compound problem. You're going to have to use the relative frequency formula to first find the probability, and then you're going to have to subtract that probability from 1 to find the complement. Now know when you're finding the complement, you subtract from 1, okay? So let's combine the 2 steps that we've done. So we know that there are 9, if you add 4, 7, and 8, you're going to get 19 total. So we're going to do this. Probability of a purple. We said how many? 19 is our total. Now, how many purple? 8. Okay. So our probability is going to be 8/19. Now, how do you find the complement? Okay, well, you can convert it to decimal if you like, I don't mind. Or you can do it just like we did example 11.db, okay? You would say 1 minus 8/19. To get your denominators to match, you would say 19/19 minus 8/19 for easy evaluation. And then 19 minus 8 is going to be 11/19, and that is your answer. Now, you could also type in 1 minus parentheses 8 minus 19, and it will give you the decimal form, and I think it's like 0.58. Okay, so I think either way I'm good with. I can grade either one of them.